Elon Musk, the CEO of SpaceX, has taken to Twitter to provide some updates on the condition of Starship, its Raptor engines, and some planned modifications for both. Musk disclosed even more ambitious plans to enhance Starship in mid-December, including expanding the ship's propellant tanks and adding 3 more Raptor engines, which could increase the ship's maximum thrust by 50% and significantly improve payload performance. Want to know more? Let's find out. Hello, and welcome back to our channel, SpaceX Planet, where we talk about space, Elon Musk, and his recent discoveries. Today, we'll tell you about the details regarding SpaceX's Raptor 2.0 manufacturing, so stay glued to your device till the end. According to Musk, as SpaceX continues to ramp up ground testing of the upgraded engine variant, Raptor 2 now operates routinely at 300 bar main chamber pressure. The engine is designed for the Starship, a stainless steel vessel currently under construction that could send the first humans to Mars. Production on the first set of Raptor engines has been cautious, with the company delivering the first finalized engine in January 2019 and producing 4 more to the present day. That's nowhere near enough to get to Mars. Each Starship Super Heavy booster uses 31 engines, while the main ship uses a further 7 engines. To put things in perspective, on February 10, 2019, just days after SpaceX began testing the first full-scale Raptor prototype ever built, the engine momentarily attained a main combustion chamber pressure of just shy of 269 bar, 3,900 psi. Russia's RD-270 and RD-180 engines, the latter of which is utilized on the ULA's Atlas V, set previous records. It took Musk 18 months to show that at least one Raptor prototype could maintain such high chamber pressure for a minute or more during steady-state operations. The same engine peaked at an impressive 330 bar, 4,800 psi, briefly producing 225 tons, 500,000 pounds of thrust, and soundly beating out Russia's never-flown RD-701 engine, which crested 290 to 300 bar in testing. Raptor isn't operational in the sense of supporting orbital-class launches for another 18 months, but the engine isn't far from its first and has already supported dozens of Starship static burns and 7 flight tests, 5 of which occurred in only 6 months. Despite the fact that Raptor 1 or 1.5 engines have yet to undertake an orbital-class launch, SpaceX has almost totally switched to Raptor 2, a new and superior type. Surprisingly, the same timeline includes no mention of a deorbit burn, which is required for the first orbital test flight to be officially suborbital, even if Starship is approaching orbital velocity. Regardless, the document reveals that Starship's orbital insertion burns will last between 5.5 and 6.5 minutes, which is the maximum endurance required of its Raptor engines. Without Raptor engines capable of continually working for about 6 minutes, Starship will never be able to enter orbit in its current design. The scope of Raptor's long-duration capabilities, and consequently the condition of SpaceX testing, were effectively unknown until high-altitude Starship test flights began in December 2020. Finally, if SpaceX can enhance Raptor 2 to 230 tons of thrust, a Super Heavy booster with 33 nearly identical engines would have a peak liftoff thrust of roughly 7,600 tons, 16.8 million pounds, corresponding to a thrust-to-weight ratio of more than 1.5, as Musk points out. A good thrust-to-weight ratio for a big liquid-fueled rocket enhances acceleration off the launch pad, decreases gravity losses in the initial few minutes of ascent, and so improves overall efficiency. Musk's suggestion that 33 engines may be put on Super Heavy is already a deviation from comments he made less than a month ago, when he announced a base increase from 28 to 29 engines with the possibility of growing to 32 engines in the future. Also new is the suggestion that SpaceX is considering adding 3 extra vacuum-optimized engines to the 6 Raptors intended for Starship, leaving the ships with 6 Raptor Vacuum (RVAC) engines and 3 sea-level optimized engines, the same variant on Super Heavy. Musk says that SpaceX has yet to decide if Raptor vacuum will be commonized with Raptor 2, boosting its thrust, or if greater efficiency will be pursued instead. Regardless, Starship would create upwards of 2,000 tons of thrust in vacuum with 6 200-ton thrust RVacs and 3 Raptor 2s, generating an upper stage with almost as much thrust as Falcon Heavy, and a fully fueled thrust-to-weight ratio of 1.7, even better than Super Heavy. The Raptor engine for Starship and Super Heavy is undergoing additional development and testing at SpaceX's engine testing site on 4,300 acres of property in McGregor, Texas, just south of Waco. The facility, which has 5 test bays, will soon become a center for Raptor 2 engine assembly, and a new factory is being built. Musk unwittingly live-tweeted one of the first Raptor 2 static fires on October 24th, revealing that the engine achieved a chamber pressure of 321 bar, 4,650 psi, and produced roughly 245 tons, 540,000 pounds of force before destroying itself. Musk claims that Raptor 2 prototypes are now frequently working above 300 bar without major difficulties, indicating that they can ignite and safely shut down after burning for several minutes at those pressures. In theory, given that 300 bar is Raptor 2's targeted chamber pressure at max thrust, that means that the engine is now routinely operating at the level SpaceX wants and needs to take Starship to the next level. It's likely that 1 or several months of work remain before SpaceX can begin qualifying the first Raptor 2 engines, or more importantly, hypothetical Raptor 2 vacuum or boost variants, for the first Starship or Super Heavy prototypes designed for the new engine. Nonetheless, the rapid progress SpaceX has made in the first few months of Raptor 2 testing is extremely encouraging. Since September 2016, the Raptor engine to be used on the Starship spacecraft and Super Heavy booster has undergone test firings at McGregor. The engines, which have been upgraded over time, are currently built at SpaceX's main factory in Hawthorne, California, then transported to McGregor for testing. Flight units meant for the Starship program are currently tested at McGregor before being driven to the Starbase launch facility in Boca Chica near Brownsville, Texas. As Elon stated in a tweet, the factory, will be the highest output and most advanced rocket engine factory in the world. He believes it will be needed to support high-cadence Super Heavy operations, including many flights to Mars related to the build-out of the planned Martian city. That said, this is it for today's video. So what is your take on this matter? Tell us in the comments. If you want to see our upcoming videos, ring the bell icon, and don't forget to like our video as well. That's all from my side. Thanks for watching.